Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today I will present the result of my work. For starting the presentation, let me introduce myself. My name is Herlina Basari and my partner is.
Syifa Aulia Mumpuni.
We are from Jakarta State University, majoring in chemistry, class A 2022. We are from Group 1 and our subject is English with a sporting lecture, Mrs. Irma Ratna Kartika. In this video, we want to explain how to integrate water and oil. Let's get started.
Okay, before we are going to do an experiment about the reaction between water, oil, and detergent, I will explain about water, oil, and detergent first. So, as we all know that water is very important for us. We drink, eat, take a bath, watering plants, and other activities we use water for sure. And this is the structure of water molecule on the left side. The molecular formula is H2O, and water is a polar compound. And I am going to tell about the facts of water. 70% of Earth consists of water. Most, or about 97% of water on Earth, is seawater, which is we can consume it directly. And only about 2.5 to 3% of fresh water is ready for consumption. The next is oil. Oil is a nonpolar compound because of its long hydrocarbon chain. And one of the types of oil is crude palm oil or CPO. Indonesia is currently the worldwide largest producer of CPO. And one of the CPO products is cooking oil. Cooking oil consists of saturated and unsaturated fatty acids. If we consume in excess, a food that cooked with cooking oil that consists of a high saturated fatty acid, it can increase the risk of various dangerous diseases such as heart diseases and stroke. And the last is detergent. Detergent is an amphiphilic compound which can be a hydrophobic and hydrophilic. As you can see on the left side, the structure of detergent. The hydrophobic tail is a nonpolar because of its hydrocarbon chain, and the hydrophilic head is polar. Detergent using the light dissolve light theory, which the hydrophobic tail dissolves in a nonpolar compound like oil, and the hydrophilic head dissolve in a polar compound like water. This is the reaction between water and oil. If we added oil in water and stir it, it cannot be mixed and form two layers. It's because of the different polarity of water and oil. As I have already explained before, water is polar and oil is non-polar. So when we add the detergent in a water and oil solution and stir it, the solution is blended. It's because of the amphiphilic properties of detergent. It has a hydrophobic tail that binding the oil molecule and the hydrophilic head that binding the water molecule. Water is a polar compound because it has a dipole moment, where the oxygen atoms tend to be negatively charged and the hydrogen atoms tend to be positively charged. This dipole moment causes the hydrogen atoms in water and the oxygen atom in detergent to attract each other, thus forming hydrogen bonds. When the detergent molecule and oil molecule are close to each other, there will be an interaction between them. It's London dispersion force. London, dis London dispersion force is an attraction due to the constant motion of electrons and will cause temporarily concentration of charge on one side of a molecule, like the left picture. Next is the benefits of these experiments. First, proving the reaction between water, oil, and detergent. proving the function of detergent in a heterogeneous solution.
The tools and material needed to carry out this experiment are 1 pitch of transparent glass, 1 tablespoon powdered detergent, 1 cup water, half a cup cooking oil, and 1 spoon.
The first step is preparing the tools and materials. 1 spoon, a cup of water, half a cup of oil, and 1 tablespoon of detergent. The next step is prepare a cup of water. Then add half a cup of oil. Stir the mixture and we can see the mixture form 2 layers. After that, add 1 tablespoon of detergent and stir again until it mixed. As we can see, the mixture blends well. And it doesn't form any layers. This is the top view of the mixture. After we leave it for 10 minutes, it formed 2 layers again. And after we leave it for 2 hours, the layers are getting clearer.
Experimental result. The addition of detergent caused the oil and water to mix in a few moments, about 5 to 10 minutes. But why did this happen? Detergent that have two groups in one molecule are called amphipathic molecule. Therefore, detergent has dual polar properties. The detergent molecule has one polar group which is hydrophilic in soluble water, uh, while the other group is nonpolar in the form of a long hydrocarbon chain that is hydrophobic, or also called lipophilic. The nonpolar group of detergent will bind to the oil, while the polar group will bind to the water. Therefore, the oil will be lifted and lost along with the splash of water when we wash the dishes using soap or detergent. Conclusion. Detergent can bind to oil and water because the structure of the detergent molecule has two groups each consisting of polar and nonpolar. The strength of experiments are that it's easy and cheap. This experiment is easy to do because we can do this experiment at home and alone. Also, we can use our own kitchen tools. This experiment is also cheap because we can find the material easily in our kitchen. We don't need to buy a new one if we already have the rest of the material. The weakness of this experiment are that it's temporary and form a precipitate. The experiment is temporary because water and oil will spray again after more than 10 minutes. This happens because there are some difference between oil and water. First, the difference is polarity level as described earlier. And second, there is a surface tension that makes it difficult for oil molecule to absorb hydroxyl ion in water. And third, the mass of oil is lighter than water. This experiment is also found a precipitate. If left, if left for well, precipitate will form because detergent powder is not completely dissolved in water and form a foam.
Okay. The next is suggestion for better experiments. The first one is use a transparent glass to see the results more clearly. The second, use a mild detergent to prevent more deposits. The third one, use chemical calculations so that the composition of the materials is correct and the experiment can be better. And the last is use two types of detergent for a comparison. So this is the reference we use. It's the end of our presentation. Thanks a lot for your attention. Wassalamualaikum warahmatullahi wabarakatuh.